Good afternoon. We are the UNCC Keyboard Senior Design Team. The objective of our project was to design a virtual keyboard based on vibration localization, which works by using 3 or more sensors to triangulate a tap and translate that into a key press. Listed below are the 5 project specifications, and here are the 4 milestones we completed.
In order to collect consistent samples, 2 microphones were placed 10 inches apart from each other, and the area between these microphones were then split into 1-inch segments. 20 to 25 samples were taken using an oscilloscope and were used in our analysis software to both view and analyze these results and output graphs seen as in Figure 1 and Figure 2. Figure 1 depicts a graph of all the signals in a given segment overlaid over each other, while Figure 2 shows the result of calculating the lines of best fit based on the average time difference between the samples compared to the segments that they were taken from. Based on the collected data, the software predicted that the spatial resolution of our device would be accurate within 2.5 to 3 centimeters. With this information, the prototype was then developed by programming the microchip PIC24 Curiosity board using Microchip's MPLAB X IDE. This chip was chosen due to its high clock speeds and the built-in 10-bit analog-to-digital converter.
For the hardware design, there were 2 areas that the team focused on. A 3D modeled casing was designed and printed with the purpose of ensuring the microphones would lay flat on the surface and house the PCB itself. This was done using AutoCAD. Secondly, 2 PCB designs were made. A breakout PCB design that would use pin connectors to establish a connection to the PCB. This breakout PCB design would include 4 1x3 pin connectors for the MAX 4466 microphones and 1 2x4 pin connector to connect the PIC24F development board to the 3.3 volts, the ground, and the outputs of the microphones. Finally, a proof of concept board was designed with the idea of how this project would be marketed if we were to fabricate it. It would include not only a fully implemented battery charger, but also 4 of the MAX 4466 microphones already built into the board itself, and a PIC24FJ128 GB204 microcontroller from Microchip.
The final prototype, as shown below, uses the Microchip PIC24F Curiosity development board and the designed PCB for pin connectors. The team had the 3D test, which allows the microphones on the PCB direct contact with the tapped surface. In conclusion, the Python analysis software was developed in a way that it can be used in similar projects. The 3D printed test was designed to place the microphones in a level so they can securely contact with the tapped material. The theoretical PCB was designed as a proof of concept to include a lithium polymer battery and a circuit to recharge the battery through a common USB connector. The prototype was tested on several surfaces ranging from plywood to a tile floor. While the software calculated a favorable margin of error, the final prototype was unable to perform as expected.